think not, but yeah. But if this is not run with the log option, then it could be that we don't have that. I'm a bit surprised. I would imagine that since this is something so central to Nix, that it would be locked somewhere. But is there anything in var log? Nothing obvious. What's in private? Nothing I can see. And journal. Right. So that's the journal we were looking at. What about Nix build log journal? Remote builds. Reading logs should work. Nix store read log, but that didn't work. Yeah, I'm realizing that I don't have the chat in front of me, so I might miss things. Let's put it here. Next door query. Tried. I see no output from blah. Okay. Reading log should work. Did you specify the derivation? On historic log blah. Then yes, this seems to add additional info. Okay. Useful to keep failed. Print build log. I posted read log of past builds. Where I posted what your link appears to be only about showing log of the build that are currently happening. Oh, yes. That's what I want then. So Nix store print build logs? No. Is debug option. Let's see. Log. Impression read log prints the build log of the specified store. Sorry about that. Of the specified store pass and standard output, the build log whatever the builder of a derivation wrote to standard output, standard error, if a store pass not a derivation, Build logs are kept in the Nix var logs Nix drvs. However, there is no guarantee that a build log is available for particular store pass. So can we? We can do which blah. I see. So maybe let's go take a look at what's up in this folder. Maybe if we just watch this folder, well, that's probably going to be huge. Indeed. We could track GHC as the derivation if we find it. I don't even know whether it's going to be available here. Indeed, because if it's building it in that shell, then maybe we need to actually Nix shell. Well, I wonder what's going to happen if I Nix shell into default.nix here. Well, it already tells us that we need to rebuild. It's waiting for logs to build slots. I see. So I'm actually quite interested in seeing, because last time I saw that this was using all of the CPUs, and you know this is a monster machine. So actually can get a build slot. We have 56 cores. What's up? And 3 builds. Oh, more builds going on, definitely. 1 terabyte of virtual memory. What? I mean, we have 126 gig and only using 11 out of that. Ridiculous. Let's see. So it's waiting for build slot. So I suppose that this is also probably waiting for build slot. So we could just you know, kill him. Default builder bash GHC651. Why would you be building GHC651? 865. Oh, right. Yes, I get it. Because you're using the stack configuration of the accelerate example that I'm building here. So I'm going to actually close this window and see whether that is actually smart enough to clean up after itself. Hey, looks like it is. That's sweet. So then is this environment going to be applied? I wouldn't necessarily count on it, but so maybe I can skip the queue and build it like so. Yeah, so we have a log there. So that's nice. And we're building the MTL. Right, so I suppose the other option is that we could use a cache, right? So that's where we reach out for CacheX, I believe. And let's see. Then would we have the Haskell.Nix CacheX cache? Provide up-to-date CacheX and Nix tools. Use CacheX instead of the IOHK Hydra cache. Ah. So it's happening, but I'm not sure. Overlay. What is this? It's still necessary to use input-output Nix packages instead of the standard Nix packages to get cache hits. So it would be nice to mention it. So I think this is done in the NixOS config. I used binary cache public keys. So that's already, it should already be sort of there, I suppose, maybe. But it seems like we're not getting binary cache hits. At least not for Haskell. And it is getting 865 here, but I also saw. Why is it getting 865 here? It should be getting 810 too. So that's a little bit strange. I would imagine that since we're now in an empty folder, that it would use this version. It does say 810 here. So there's a tiny bit of a mix. This says that it's using, maybe it's using a 865 to bootstrap and it's going to build GHC 810.2. So that's, well, it is what it is, but I suppose that it means that it's actually building Haskell here. Yeah, well, I think that's life. There's probably a way to make this more efficient, but once it's done, it'll be done. And so we can probably then use this time to take a look at take a look at our log from last time. Because in there we had stuff about the library, the GStreamer library we want to use. Yeah, first of all, I should actually make an entry for today. We are the February 20th. And right, the log structure wasn't updated yet at this point, so I'm going to update it. Let's save it. There we go. And go into streaming. And right, so we had a little to-do set for us. So we already dealt with this categorization idea, but I suppose I'll leave this here. This is sort of the driving idea behind what we do on Thursday, which is sort of playing with the metadata layer and a performer overlay on the Tuesdays where we go back to GPU stuff, and on the Saturdays where we play with GES and maybe connect that to FRP things. So one of the first things that I wanted to do was to try and instantiate a GES pipeline in Haskell. And so if we look back at GES pipeline, that's the GStreamer top-level object of the library that we want to use, GST editing services. And it's going to be so nice to have Nix for this. Like the whole binary dependencies is a pretty hairy thing to do. So that's going to be very nice to have Nix there. Let's keep this somewhere. I suppose, yeah, I suppose it is where it is. Yeah, so we want to instantiate a GES pipeline, and I don't even think we saw that documentation so far. I think we saw a more GES dedicated documentation. I think it had, or maybe it's we were just focusing on the timeline documentation. The one with the diagram, where is it? Maybe it's in the top level. GS editing services. Yes, that's where the diagram is. Okay. So we found out that the easiest way to start a GES timeline is to use the GES pipeline convenience GStreamer element, but that probably we can't really instantiate that as we would existing GStreamer elements, I think, because there's some methods that seems like they're non-standard for GStreamer elements, but I might be wrong with that. And so the main thing to look at here is the GStreamer library in Haskell. That's something we haven't looked at all last time, and we want to look at what's in the ecosystem there. And there's some stuff from 2018. I'm going to want results in English, and GStreamer plugin usage, why not? But Haskell GStreamer on Launchpad, a Caldi GStreamer server Haskell client. That's interesting. I kind of want to take a look at that. Caldi being the text-to-speech library, like more like a research framework. And whether I'm Manjaro, we don't really care. Transcoding API in GStreamer 118. Oh, didn't realize that. Live loudness normalization. Install libghc GStreamer dev on Ubuntu. Okay, looks like what we really want is to narrow this down to Hackage, I think, and actually we just want to be on Hackage and search for GStreamer up in there. Right, there are more libraries than were showing up, and there's right. So the GI stuff is the recent stuff, but it might be depending on GStreamer. Let's take a look, and it doesn't. So I think it's all a more modern version of the than the GStreamer bindings there. So let's see. So right, so 0.12.8. Okay, that's where the repo is. No README and cabal file and GStreamer doesn't even say which GStreamer version is binding to. I mean that I can see. It's not saying it at the top, which really it should. glib GStreamer 0.10. So that's pretty old. And then let's look at these guys. They're auto-generated, which is really awesome, and updated 12 days ago. That's definitely what I like to hear. It actually also has an OSX binding. That's really nice. And it depends on, doesn't say right here. Okay, let's look at the docs. Using the generated bindings, So does this just generate the binding of whatever GStreamer you have installed on your machine? It's not specifically for GStreamer. This is for just for GI. So, which is an introspection, and so the GI GStreamer, that's the specific bindings. Oh, but that's actually the same. Yeah, it's the same. So I suppose GStreamer in itself has specific overrides, I see, and a change log. Okay, that's not the GST library, but what about overrides? GST 180. Okay, I think we're at 118. So if that's really what it is, then it's a bit old. pkg.info. GStreamer 1. Better than 0.10. That's definitely more recent, but I think we are at 118. Let's double check that. It's in GitLab. And GStreamer. No releases. Must be in the change log. Oh wow. 4 megabyte change log. Yeah, that's pretty rare. That is a huge change log. Okay, while the change log's loading, I am going to put the terminal window on there, and I'm going to grab myself some drink. I'll be right back. Okay, still loading. Ah, there we go. So indeed, latest version is 118. So will this work with 118? Oh, let's look at the issues. DTK, people bind it to all sorts of things that have the GI capability, but yeah, GAGST compared to GIGST tag and GIGST P for plugin and B for base util. So it actually specific bindings to plugins. In fact, to specific plugins. And there's some auto-generated documentation. And so I think, where were we? It's the objects that are the things. And oh, what's up there? Hey, it's doing some make things. Audio visualizer, what's that? Base class for scopes. Take care of refitting the audio rate to video rate, handles renegotiation. Okay, so that's a base class for a certain type of plugins then, I assume. Discover. Huh. This is not immediately obvious. But it could be that with functions we can actually hook into the GES timeline pipeline thing that we're looking at. Oh, there's a bunch of stuff in here. I wonder, so this is all GTK to HS. Oh no, that's the old stuff. Okay, let me open these in a separate window, because we're already getting a bit tapped out. Right? Does this work? It does. Okay. Let's search for GStreamer, see whether anyone is using it for this. DST base for GStreamer 110, GStreamer 18, that's from 2016. A GStreamer example. Oh, there is a GStreamer example. Well, I like that. And that's an example GST Hello World. Let's see whether that's the most recent or whether something's been added since then. Examples. Okay. Introductory source. Nothing in there. Advanced. GST Hello World. Rework type hierarchy 8 months ago. Yeah, so it's been updated since then, so we can close this. And this, yeah, GST GTK X11. And this signal stuff. There's a Cabal file. So we can probably, and as support for GST 901. Whoa, that's super recent. We're in 8.10, but I suppose 8.10 is going to also be supported. And so if we look at the GST Hello World example, for instance, so it depends on base and Haskell GI base and GIGlib, GIGST and text, and that's the stuff. Okay, great. So let's look GST Hello World. Import glib and GST. import the set object property string. And what's the main? Get the program name, arguments to gst.init. glib main loop new, nothing false. Well, we just want to try and run that, I suppose. It takes wants to use an ogvorbis file apparently. Oh wow, on pad added. Oh, I'm already feeling nice about this. All of this means like you can have event based on pad changes. That's awesome. And it means that we'll have a way to hook this into an FRP paradigm as well, I think. Okay, let's continue reading. So it inits creates a main loop from glib. So that's something I'm not familiar with, but yeah, we'll see. Check input arguments. What's going on there? Some garbage collection tests. Looks like interesting. Huh. Check input arguments. Yeah, right. So it wants some ogvorbis file name. If it doesn't, then it exits. Then it creates a new pipeline with just an audio player in it. So GST pipeline new, that's definitely going to be one of the core things that we'll want. And that's going to be where GST pipeline right there. And GST pipeline new is here. New pipeline new takes a maybe text for the name of the pipeline and returns a newly created pipeline. So it's empty at this point. Then we make an element using the element factory. First we make a function that's called make element. That will take a factory and a name, and that will be a wrapper around the element factory make function. And the element factory make function is probably going to be in element factory, and element factory make, not create, make is at the end. Create a new element of the type defined by the given element factory. If name is nothing, the element will receive a guaranteed unique name consisting of the element factory name and a number. If name is given, they will be given the name supplied. Okay, so those are pretty, I think, standard things, right? So we make the element with the factory name, file source, and it's of the type file source. So that's now this file dash source thing is a proper GST. A proper GStreamer thing. So let's find file source. Could there be a mapping from Haskell names to GStreamer names here? Maybe text name of new element. Or is it an empty element at this point then? Like the pipeline, something will instantiate later. Maybe it is. Although these names, they look quite like they're real things. File source seems like there is a file source element, I'm pretty sure. File source, my file source. So it's really similar to this. GST element factory make blah. So in fact it doesn't matter at this point, they're just names. Okay, so it's just declaration at this point. We haven't assigned any functionality yet. So I suppose this is going to happen next. We set the input file name to the source element.